We were all excited about the power and potential of the James Webb Space Telescope before it flew. Well, now it's launched, in its science orbit, and staring out into the universe, it's exceeding all expectations. The most powerful telescope ever launched has already given us clearer images of old favourites for astronomers to pore over. It's found the oldest ever galaxy, examined the constituents of the atmosphere on a planet impossibly far away. But now the telescope has made its first confirmation of a faraway planet. And it's very exciting because we now already know a lot about this alien world. So back in 2018, NASA launched a planet hunting telescope called the Transiting Exoplanet Survey Satellite, or TESS. This isn't able to confirm the existence of faraway worlds, but it stares at around 200,000 stars looking for a dip in the light as an object passes in front of it. Almost 6,000 of these candidate planets have been found by TESS, ready for another telescope or method of detection to confirm they're real planets. Well, as luck would have it, the James Webb Space Telescope is up and running, gathering data and still looking to test out its capabilities. And it's not confirmed an exoplanet yet, so it turned its attention to a tiny patch of sky in the southern hemisphere constellation of Octans, where TESS suggested there might be a star with an exoplanet. The star in question is a red dwarf star, about a fifth the size of our Sun and much dimmer. And it took just 4 days for the James Webb Space Telescope to confirm that this is indeed a planet 65,000 times further away from us than Pluto. The star's called LHS 475, so the planet's named LHS 475b. That's the naming convention for distant star systems. And it's astounding to think that when Star Wars was released, there was no evidence at all for any planets existing outside our solar system. In fact, when The Return of the Jedi hit cinemas, it would still be another 9 years before we would actually know of another world beyond the 8 in our solar system. 9 if you want to get cutesy and include Pluto. By the time The Phantom Menace menaced our screens in 1999, we were pretty sure there were loads of planets scattered across our galaxy because we'd found exactly as many planets outside the solar system as we have in it. And that exploded a whole new exciting field for astronomy in exoplanet hunting. In simple terms, if it's inside our solar system, it's a planet, and if it's outside our solar system, we call it an exoplanet. And those 8 new faraway worlds that we'd found by 1999 encouraged NASA to propose a mission to specifically look for other worlds out there in the galaxy. We'd found 8, so how many more could we find if we launched a dedicated planet hunting telescope? Possibly none. We might have already found them all, and this would be just a waste of $600 million. But the first exoplanet discoveries were so exciting that NASA greenlighted the Kepler Space Telescope, and it was launched in 2009, discovering more than 2,600 distant worlds. NASA then built on the confidence that Kepler gave them, confidence that the galaxy probably has billions of planets, to look for planets around stars closer to home. So TESS was built to look at the brightest stars nearest to Earth because, well, we can get clearer data on them, but also closer stars have the better chance of being contacted if we discover any of them harbour life. And that's the holy grail, right? While all data on faraway exoplanets is useful for astronomers to understand the abundance and distribution of planets throughout our galaxy, for the public, there are 2 things we're anxious to find: Earth 2.0 and signatures of life. And among the 6,000 nearby candidates that TESS saw, the JWST team picked one out to test this new wonder telescope's abilities. And because we have the data from both TESS and JWST that have different instruments and capabilities, we can tell a lot about this alien world, even though we're centuries away from having the technology to be able to see the surface of a planet so impossibly far away. So what do we know? Have we hit the Holy Grail? Well, we know it's a rocky planet like Earth, and we also know that it's about the same size as Earth. We can't yet tell if it has the same gravity, as we need more data to constrain its mass, but if it's rocky, its gravity will be broadly similar to Earth's. Just depends on the size of the core and the mantle. We also know that it doesn't have a thick methane atmosphere like Saturn's moon Titan, which is also a candidate for microbial life in our solar system. But we can't rule out a thick carbon dioxide atmosphere from the preliminary spectroscopic data. But as the planet orbits so close to its parent star that it completes an orbit once every 2 days, for reference Mercury's orbit is 88 days, it could be getting blasted by solar radiation that strips it of its atmosphere altogether. We'll know about this for sure in the summer when James Webb's tasked with taking more precise measurements. We've actually found a lot of rocky exoplanets already, but we don't know much about their atmospheres because we've not had a telescope equipped or powerful enough to examine them until James Webb. So this is going to transform our understanding of planetary atmospheres. As it stands, we only know in detail the atmospheres of the planets in our solar system, and we therefore assume all planets' atmospheres must be like one of them, just in the same way we thought our solar system of 8 planets with rocky planets near the sun and gas giants further out was typical, until we were able to detect thousands of star systems and find our model is actually quite rare. When JWST has probed the atmosphere of dozens or hundreds more, we'll have a much clearer picture of the alien worlds that exist, and perhaps even if aliens themselves are living on any of them. And that's not an exaggeration. If JWST identifies molecules that can only come from biological sources, such as ozone or industrial chemicals, we've all but found life on those worlds. And that's why it's so important to keep analysing the atmospheres of hospitable rocky exoplanets, because any one of them could be the jackpot. In fact, who knows if life exists in a different form on worlds that are inhospitable to us. Recent research hints at microbial life in the cloud tops of hellish Venus. Something we've now got to go and take a scoop of to sample back on Earth. What a mission that's going to be. But because JWST is so capable in so many fields of astronomy, it can only commit a tiny fraction of its time to just probing alien atmospheres, which is a hell of a shame. And that's same for the extremely large telescope, which will also be capable of analysing exoplanet atmospheres when it comes online in 2027. And it's for that reason that I'm pretty certain that in the next decade, NASA or ESA will be commissioning a telescope dedicated to rapidly and continuously analysing the atmospheres of exoplanets. And how cool would that be? What do you think about such a telescope? Would it find life, or would it just be like SETI listening for radio signals across the sky, searching for a needle in a haystack that still doesn't seem to be there? I think it's a fascinating prospect. And if you've got this far, this is clearly something that interests you, so you'll love these videos on our search for exoplanets and life out there in the universe.